area of polygons notes. Okay, first we're talking about a polygon. A polygon is a closed figure with 3 or more straight sides. So some of your polygons that you know would be a triangle, and that includes all the types of triangles: right angle or right triangles, scalene triangles, isosceles, equilateral, all of those kinds of triangles. Quadrilaterals are polygons because they're 4-sided figures. So that would be your square, your rectangles, your parallelograms, and your trapezoids. Pentagons are polygons, okay, because they've got 5 sides. Hexagons, heptagons. Okay, so we've gone 5-sided figures, hexagons are 6-sided figures, heptagons are 7-sided figures. We could keep going on and listing, okay, but etc. So 9-sided figures, 10-sided figures, 12-sided figures, they're all polygons because they have more than 3 sides, and if they're all straight, then it falls into the category of being a polygon. When we're dealing with polygons, we have regular figures and irregular figures. A regular figure is a figure with all congruent sides and angles. Okay, so these are the octagons and the hexagons and the pentagons that when I say those names, you visualize in your head. They have, like a stop sign, has all equal sides and all equal angles. That is a regular octagon. Okay? We're going to focus in on parallelograms today. Parallelograms are a polygon with 2 sets of parallel sides and congruence, and 2 sets of congruent sides. Okay, so here we've got a parallelogram. It's got 2 sets of parallel sides. These symbols here represent that they're parallel. And it has 2 sets of congruent sides. The red side is the same as the other red side, and the green sides are congruent. Okay? A rhombus falls under that same category. It's got 2 sets of parallel sides, but then all the sides are the same length. So that still falls under the category of being 2 sets of congruent sides. Okay? A square is another one, is another parallelogram, and so is a rectangle. Okay? Alright, so let's get in finding the area. To review, to find the area of a rectangle, the equation is length times width, but we can also call that base times height. Okay? Because over here we've got the base, which is the same as the length of the rectangle, and we've got the height, which is the same as the width. Okay, so those terms are kind of interchangeable when we're talking about rectangles. To find the area of a parallelogram, surprisingly, the equation is the same as a rectangle. Okay? Let's move down here and talk about why. Okay, right here, I have a parallelogram. If I take that parallelogram and I cut it, okay, right where that line's passing through it, and I move the portion that I cut, notice what kind of shape it makes. It makes a rectangle. Okay? So, parallelograms are just like rectangles. Here's another version of a parallelogram. If I cut it right there and move that portion over to the side, notice how it would make a rectangle if you focus in on just the portion that's left behind. Okay? So parallelograms, the equation for a parallelogram is the same as the equation for a rectangle because they are the same shapes. Rectangles can be made into parallelograms and parallelograms can be made into rectangles. So they have the same area. So you use the same equation to calculate that area. Okay? In this portion here, on your note page, I want you to answer in your own words that question. Why is the equation for a parallelogram what it is? So explain to me. Okay, this is kind of your reflection piece of these notes. Explain to me in words why the equation for a parallelogram is what it is. Okay, and if you need to, I'm going to move on, but if you need to, pause the video as you write that answer, because I will need to see that when I check your notes. Okay, going into some examples of calculating a parallelogram's area. Again, the equation equals base times height. So I need to identify the base. The base is always in here, or it could be labeled up top. Okay? These are the same. Remember, they're congruent sides, so the numbers are the same. This would be 8 centimeters also. Okay? So B is equal to 8 centimeters. The height is always the straight side. Okay? There is no straight side on this parallelogram, so it's got to be marked in the middle of the parallelogram. Never use an angle side for the height. Okay? The height is 4 centimeters. If I calculate, that's 8 centimeters times 4 centimeters. That gives me 32 centimeters. And remember, when we're calculating area, our units are squared, because that is showing me that if I take little centimeter cubes, or sorry, not cubes, little centimeter tiles that are flat, and I laid them out, they're 1 centimeter by 1 centimeter, it would take 32 of them to fill in this whole shape. Okay? Alright, moving on to example 2. Here's another one, just set up a little bit different. Now the height is labeled outside. Okay? That's the way you may see it. I just wanted to show you multiple examples. So my base is 8, my height is 3, so that gives me 24 centimeters squared. Okay, and at any time if you feel like I'm going too fast, you can pause it. That's the nice thing about these videos. Okay, I just had to label my answers there. Alright, on this parallelogram, it's turned. Okay? So you've got to think about which one is the base, which one is the height. In this case, the base is the 12 inches, because if we turned it back, we put this down here, that would be the base. And the height's passing through the center, so that's our height. Oops, and 8 inches. So 12 times 8 gives us 96 inches squared for our answer. Now, would it make a difference if I had flipped the base and the height? No, because that commutative property tells us we can change the order and it's still going to get the same answer. Okay? Alright, on your page, there are 2 more individual practice problems. You will solve those. Make sure that you show your work in the workspace that it says.